Hi, my name is Shiva, and today I'll discuss about the topic that is disease symptom prediction using the machine learning. And this is related to the course ITC 6480. For this project, and the problem statement is healthcare is facing some challenge in terms of misdiagnosis. For example, there is there is some miscalculations, or it's taking some time in order to handle some complex symptom patterns. So this is related to can be preliminary health screening or it can be hard diagnosis. As our challenge here is about the disease symptom prediction. So for that, we are creating a model which can understand the symptom and find out the disease and populate the treatment for it. This is what we are trying to achieve using the project. So the technology and the selection, which talks about the how machine learning can help in the healthcare. For example, it can identify the medical data and its complexity and its different forms of data, and it can be converted into an application which can be available for 24 by 7 and which can help the people by adding the continuous improvement in the data and make it more scalable and available for more people using different forms of applications. And there can be some challenges in implementing it in terms of regulations, HIPAA and HDA. There can be some quality issues. For example, if there is an X-ray machine which is creating a data, in case if the machine is faulty, it can write a incorrect information or wrong values in the data that can create a data quality issues. And there are some other bias issues related to the machine learning. Coming to the next slide, this talks about the data set which we considered here for this project. So the data set is from the Kaggle. It contains of 4,920 records and different diseases and the symptoms. So in order to work on this data set, here we considered five algorithms such as random forest, gradient, and some other loss regression models in order to work on it. So here, this talks about the ML pipeline. So in the feature engineering, there are like 40 features which are considered here from the raw data set. And symptom presence indicators are being converted into the binary 0, 1, and the severity weights into the numerical. As we talked about before, we consider different algorithms to test to on this application this model. And here we consider five-fold cross-validation, which gives the proper results. And here we are considering the F1 score, as a result for our models. Coming to the model comparison, here this chart clear, explains about how different models use the data set and and provide the results. So here we can clearly see the random forest is performing well, and in terms of um, it analysis, and here we can see it's giving like 85.25 accuracy and the ROC of 99.59. And if we see the other models like gradient boosting and logistic regression, they are not up to the mark as the random forest. So here we can clearly see like random forest is better. And even if you see the FN score, random forest is giving the best results. Here, the feature importance. Here we can see the weights. So, well, it's something like the AI thinks like a real doctor, like understanding the how the patient feel overall, and it also tell about all the symptoms, and also the overall how the bad the patient is feeling. So that chart clearly tells about all the values which are giving good in the random forest. Coming to the ROC analysis, this ROC chart, which provide the combination of five results. As we can clearly see, there is overlap in the results. So in order to explain that little better, I created another column chart with the proper values. So based upon the value here, we can clearly see that random forest is giving the best value, which is 0.9949 compared to the other models. So here we can clearly see like random forest model can be used well for our symptom prediction. And again, this talks about specifically for the random forest. So here we can see the overall ranking. The random forest is the best. And even when we see about the performance and the stability trade-off, the, the trade-off is very good with the random forest because the performance and stability talks about how accurately the model is performing and how much consistent the model is, you know, um, working well. So here the clear winner is the random forest. As we consider, I mean, in the chart C, we consider top three models and their metrics. So here also we can clearly see like random forest is good in the results of F1 score, the precision recall. So considering all this metrics, random forest is the giving the best result. And this slide talks about from the collection of the data set to the final deployment of the chatbot application on the EC2 instance. So here the raw data talks about the data which was downloaded into the local machine, and this script combines all the different data files available in different CSV files are combined and placed in a staging area. The process files is nothing but the combination of the files which required for this uh, project. For example, the ML pipeline, the application code, here it is the Flask API, API.py, HTML, Nginx, and GUnicorn files. All the files are pushed to the GitHub repository, and this GitHub Actions is a pipeline which initially triggers a Terraform and provisions a EC2 instance. After that, the ML pipeline triggers and it creates a model validation, and finally the best model creates the artifact. So that it is the pickle file. Along with it, it combines the dependency uh, application pack files, and all will be packed and deployed into the EC2 instance, which is newly created for the this specific project. This chatbot application setup scripts are nothing but the moment the artifact is deployed onto the EC2 instance, these files will set up this complete application runtime on the server. For example, installing the dependency packages and properly configuring the G-Unicorn and the Nginx. So here G-Unicorn hosts the Flask API with the port number 9090, and Nginx does the reverse proxy by hosting with the port number 80. So the moment when we hit the URL of the EC2 instance using the port number 80, it will be resolved, or it will be go to the Nginx, and again Nginx will connect to the G-Unicorn from the port 80 to 9090. Again goes to the HTML. The entire flows, goes in this way. So this is the architecture of the AWS, and here we can see the user hit the URL. It goes in this specific flow. The internet, the gateway, and the routing table, the VPC, the subnet, and security group, and the EC2 instance, as well as the specific the key. And this will be taken care by the Terraform scripts. This slide talks about the web application integration, and we have a Flask API that loads the random forest model, and it also has the API calls, which is analysis, and the suggestion symptom, which is nothing but it auto completes the symptom, which I'll show you in the later PPT or the demo. And here we can see the treatment, the based upon the disease, that's treatment, the specific treatment will be populated. That also we can be uh, displayed in the later sessions. And this is the health. The health talks about, for example, so this is the health. The moment when the specific API is hosted, there is a Swagger health, which can be used to know the health status of the API in case if it goes down. In future, when it goes to a production server, it can be integrated to the specific health monitoring tool, and eventually we can connect to the PagerDuty. PagerDuty again connected to the mobile specific mobile application. If in case if this application goes down, it will be within some period of interval, it will trigger the pager alert. Pager will eventually connect to the proper team. Coming back to the slide, again we have HTML, which uses a Java fetch in order to call to the API. The specific um, symptom, it will connect to the specific API call, and again it populates from the random forest model. And we also I mean, here there are some features like emergency protocols, and which I'll show in the later slides. So this is the pipeline. Basically, the entire process, instead of doing manually, it is achieved here using the GitHub CI/CD implementation. So the code is available in the GitHub, and GitHub Actions will provision the instance, and after that, the model get trained, validated, and the proper results will be populated, and even the configuration of Nginx, all will be taken care here. So for this, I'll show you the GitHub Actions pipeline, which I will trigger now. By the completion of this slides, we can see how the application is deployed on the EC2 instance. We can collect the latest IP address from the GitHub Actions, and we can host, and we can see the functionality of the chatbot. So this is the GitHub Actions, and this is the CI/CD pipeline. So now I am triggering the job. This pipeline will provision the EC2 instance, After that, it will build the model and it deploys on the newly created EC2 instance. This will take some time. The meanwhile, we'll go back to the slides and know about the project. Yeah. So next it talks about the web application implementation. So this is a chatbot and is hosted on the web application. And as we know, it is has a different features in it. And as it based upon the specific symptom, it will populate the disease, and it also integrate with the emergency protocol integration like 911. I'll show you in the next slides. And also generates the clinical report, which we can export and save in our local. And even we can save the chat as well. So this is the EC2 instance, which will get created automatically based upon the Terraform scripts. And this is the health check URL, which I already showed in the before. And this is the main screen of the chatbot. Here, I integrated the dark and light mode toggle. So using that, based upon the user convenience, I mean, they can switch to the light or dark mode. This is the feature which I'm talking about, the emergency service. The moment user is experiencing any emergency, so they can click on this button, which will connect to the 911 service, and which will share the location of the patient. And this is the autocomplete, which I'm talking before in the API slide. So the moment when I type the pain, it will start auto suggestions, and we can select and we can go forward. And these are the symptom disease prediction. Here we can see there is a two predictions, and even it has a the ratio of it, the confidence intervals. Here we can see for the migraine it is 20%, and the influenza is 14.3%. And AWS deployment validation. The moment the instance is created, there is a application deployment happens on EC2 instance. So which invokes uh, some scripts that create the application environment and configures the G-Unicorn and the Nginx. This is the SSH connection. This Terraform script will create a SSH key, and I just wanted to validate whether that creating key is connecting to the newly provisioned instance. This clearly tells like that key and the server it's properly connecting. This is the slide talks about it. And these are the logs of the Nginx and G Unicorn. If I mean to validate whether that it's properly working or not. And here we can see G Unicorn is listening on the port number 9090 with the two worker process, and Nginx logs. We can see the uh, access log, and we can see the get response, specific response. Here we can clearly see the get response for the symptom, and the analysis is doing the post by connecting to the ML model. And this slide talks about the status of Nginx and GUnicorn. And this is the conclusion. The conclusion talks about the major accomplishments which happened in the project. And the first one um, talks about the ROC of the random forest, which perfectly classified the disease patterns, and the ML automation which we did using the GitHub Actions. And AWS deployment of the application, chatbot application using the Nginx and the GUnicorn. This application can be further more, enhanced. We can do it. We can enhance more, like adding the LLM model, and we can also do the hybrid model based upon our requirement. And by introducing the continuous data integration in it, and new symptoms and diseases can be integrated in future. And coming to the AWS EC2 instance, that can be transformed into a Kubernetes architecture with auto scaling features. Even it can sustain the heavier loads and can provide a zero downtime here. Um, and we talk about the enterprise security with the compliance and the SAML SSO and zero trust uh, architecture. So let's go and check about the CI/CD pipeline. Well, the here we can see EC2 instance is provisioned and ML deployment is happening. We can clearly see like Nginx is configured and Nginx restarted. And here we can see that it's taken care the even the backup of it in case if there is any application configuration is active, it takes the backup of it and performs the new deployment. So this will take care about the end-to-end deployment cycle. So here, as we got the new EC instance, we can, this is the IP address and DNS name. So now using the IP address, now we can, trying to access the chatbot. So we can clearly see I have considered here the newly provisioned EC2 instance public DNS name. Now it will connect to the Nginx with the port 80. So that's the reason I did not use any port number here. So because it used the port number 80 for the HTTP request. If you add in certificate, it can go to the HTTPS. And this is the main screen of the uh, chatbot. Now we are selecting the disease symptom. Here we have a single and the multiple selection. If I select here, I can select multiple symptoms and I can click on, we can see there's a it's populating. Here it is 4, now it is 3. You can select 5. And if you want, we can select some more in the next page. As of now, we selected only 3 for our testing. So now it we selected 3 symptoms and it clearly shows like 3 symptoms selected. And we can click on analysis or we can add some more. So I'm clicking on analysis. Now it is checking your symptoms and it is checking with the machine learning model which is available. So Flask will connect to the machine learning model. And it loads and it checks the appropriate response for that. So here we can see for that 3 symptoms, they are like 4 disease, 4 matchings. So here we can see the confidence interval which is for 42.9 for the influenza and 20%, 20% less for the cold and migraine. So here we can also select like, it's helpful. It's considered as a feedback. And it shows like, the summary report and treatment operation options. And we can click on, you know, the new symptoms if you wanted. Here, again, it populates the symptoms. Again, we can select multiple, or we can select chest pain. This is a single selection. Initially, we tried for multiple. This time, we are selecting single and click on analysis. It says like it's checking with the medical database. The medical database is nothing but in our model, the random forest model, and these are the results which are populated from that metadata. And here we can see, you know, the treatment options. Here we can see the, when I can see the doctor in case if there is an emergency, and based upon this we can follow that. And even we can start the new assessment, or instead of that I can type it here. I can see the auto completion of it. I can even type chest pain here. That will even show the symptom. I can click on analysis. So here the model works by selecting the auto-populated options, and or I can manually type it here, or auto suggestion, sorry. So it will, there are many ways here, and I can give a feedback here, and I can select this will again consider for our future how the model is working, and we can improve it. And this is the emergency button which I was talking about before. So if I click on this, it will immediately pop up saying like, whether we wanted to, make a connection with the 911. If I type this or select that, so now this chatbot has a feature that can immediately contact the medical service and the 911. So this will actually help the people in emergency situations. So I just added this feature so that to consider, because in future sometimes people might accidentally uh, enter that button. So there's an option that can, you know, help to skip that or bypass it in order to return to the main page instead of avoiding the uh, emergency contact. And again, we can start the new symptom, or there is a button here which goes to the top to the main. And I can select here the button which actually clean the complete chat history, and this button will helps to export the entire chat conversation. We can save it data. So I can change the web page appearance and emergency button. I can save this icon complete chat. So this is all about the application, and that's all. I hope you like this chatbot. And we can also advance this based upon the models, and we can also expand this into the AWS in different Kubernetes and different Lambda functions, and we can do that based upon the future enhancements. That's all for the video. Thank you for watching.